Okay, this is the experiment simple harmonic motion, part B, the spring elongation. And I'm using a University of Colorado at Boulder PhET simulator at PHET. You can see the symbol here. We appreciate them producing this simulation. And what we're going to do is we're going to suspend a mass from the spring and see how far it stretches, so that we can measure the the spring constant K. And you can see that if you make the spring constant small, I don't know if you can see it, but the wire appears to get smaller, and the mass, uh, the amount that it pulls as spring is much greater. Now, if we make it a large spring constant, you can see that the coils get thicker, and the 100-gram mass doesn't pull it down as much. So we're going to play with this. We're going to use some tools that they give us to. We're going to first, let's take off the mass. We're going to use the unstretched um, uh, indicator, and we're going to use the resting position, and we're going to start with the smallest weight possible, 50 grams. And so we put this on, and let's stop the oscillating. Oh, I want it, we'll just choose I've done it before, so we'll choose um, a spring constant there, not the smallest, not large, but kind of on the small side. Now, how are we going to measure that? Well, they provide us with a ruler here, and we're going to use this ruler to measure from the resting point the unstretched length of the spring to how much it's stretched. And it's about uh, 10 centimeters, um, 0.1 meters. And so that's a data point. Now, I'm not going to bother to go back and forth. You can take this data down, but I'll provide you with the data. So at 50 grams, 0.05 kilograms, we have a stretch of about 10 centimeters. It looks a little smaller than that, but this resolution, at this resolution, we'll just round it to 10. And so now let's increase this to 100 grams. And you can see it stretches a bit more. Let's stop the oscillation. And, well, it's still close to 20. So I'm going to put it down as 20. Even though, yeah, what are you going to say? 19.7? That's a little uh, wishy-washy. I mean, it's a little hard to tell. I'm going to put down 20 or 20 centimeters, which is 0.2 meters. Now let's increase it to 150 grams. Stop the oscillation. And where is it now? Now there, it's closer to the 29 than it is to the 30. So I'm going to call it 29. Okay, now let's increase the mass to 200 grams, 0.2 kilograms. Stop the oscillation. And it's at 39. We'll call it 39. And let's go to 210. 250, not 210, 250. Stop the oscillation. And it's 49. It stretches to 49. Let's go all the way to 300 grams. Stop the oscillation. And it's a little bit less than 59, but I'm going to call it 59. That's that's our experiment. We've applied a force, mg. We've applied a force to the spring, and we've seen how much the spring is elongated. And let's look at let's share a different screen. Let's go to the iPad, where I've already, oops, well, it says it's connected. It says, Okay, there we go. And I've already populated the table. So we've got for 50 grams, 0.05 kilograms, we got uh, uh, 10 centimeters or 0.1 meter. 100 grams, 0.2 meters. 150, 0.29. 200, 0.39. 250, 0.49. And 300, 0.59. Now, your job is to make a little, if we go up here, we want to do a little chart like that where you have mg on one side and y on the other, and I've done it. It's pretty small. I'd like you to do it on graph paper, or you can use Excel. If you don't know how to use Excel, if enough people request, we'll do a little session, and I'll show you how to do a linear fit to this data, and even display the trend line. And uh, if you know how to do it, great. You're welcome to do an Excel spreadsheet. I encourage you to do an Excel spreadsheet. That's something that you can definitely use in your. It's certainly a skill that people look for. So I encourage you. So you plot mg on the vertical scale and the displacement y on the horizontal scale, and you get the. I just kind of eyeballed and drew these in. I did use a graph paper on my iPad, so it's pretty close. And you draw a straight line. Now you pick points that are not the data points. You might pick uh, a, you just draw your best. Well, red is good enough. We just draw your best fit line. And then you pick points that aren't on the line, like that might be a point, and that might be a point, and then you get the slope. So the slope equals, you know, we'll call it mg2 minus mg1 over y2, y2 minus y1, and you're going to get a slope, and that slope will be the spring constant, as long as you do actually multiply it by the gravitational acceleration, 9.8 meters per second squared. And all right, that's I think that's it for this discussion. We'll go on and do the period next time.